Thank you for joining our webinar today. We've got a great topic on running Apache Spark at scale in the cloud, and we'll be taking a closer look at Qubol's version of Spark. We do want today's webinar to be interactive, so if you have any questions during the presentation, please submit them and we'll answer them as we go. We will also be recording today's webinar, and we'll share the recording and presentation following today's live session. Thank you again for taking time to join us today. I also want to thank our speakers. Ashwin is a Senior Product Manager here at Qubole, and Harsha is a Senior Solutions Architect. They will be driving the presentation today. So with that, Ashwin, I will hand it over to you.
All right, thanks, Steve. Hey, everyone, this is Ashwin. So today we will be talking about Apache Spark and what it is, how it helps with big data processing, and what does Spark on Qubole mean, right? How we provide Spark as a service to you and to cater to your use cases. To just step back and then look at the big picture view, why Apache Spark, right? So today the data volumes have been exponentially growing. The studies that IDC conducted over the last 10 years or so. 2025, they basically have predicted that the entire data size in the world would be 160 zettabytes, right? And it's growing about more than 400% over a span of 5 years, and that is huge amount of exponential data growth. And for your data processing, so that you can provide insights for your business, there have been traditional ways of doing data processing, which were node, single machine kind of processing, and these traditional tools, they started taking longer and longer to process data, and a lot of times because of the scale of your data, it's not even possible to do some processing on these traditional tools, right? So as a result of that, there is a huge need that got emerged in the market, which is need to actually solve scalability in data processing, and actually processing engines actually came to the rescue, right? So as you see over the last few years, there have been multiple open source engines that emerged that actually started to solve these scalability problems for data processing, right? As you can see here in a graph that shows data volume in the y-axis and the processing speed on the x-axis. At scale, you will see that the traditional ETL products and traditional data stores, they are non-distributed, right? And essentially they start to become slow, they start to become siloed, and they are not scalable as data volume grows. And over the years, multiple open source engines have emerged. So Hadoop and Hive have been pretty popular for distributed data processing because of certain features that they bring in. They are scalable, right? They process data in a distributed fashion, right? So if you have, let's say, terabytes of data, they take your data, chunk it into smaller data sizes while processing, and then parallelly process them so that you can get your results faster and be able to work on large amounts of data sets. Right, and they are fault tolerant as well. So let's say you're working on a 1,000 node cluster, and one or two nodes might just go away because of some reason. They don't stop your processing. They will actually heal themselves and redo just the same amount of processing in some other node, and then continue to process to finish your processing jobs. That way they are pretty fault tolerant, right? And they're also flexible. They cater to multiple types of data formats. So for example, they cater to traditional structured data, but they can also process unstructured and semi-structured data such as JSON, XML, CSV, and so on, right? And they were pretty good. They used to scale well. A lot of our customers actually still use Hadoop and Hive, but they are not fast because a lot of this processing, while it is happening, you have to hit the disk with gigabytes of data all going back and forth between disk and your memory throughout the entire processing. So Spark actually came up as advanced data processing engine, which would do processing similar to Hive, except it tries to do it as much as possible in memory. As a result, what happens is the amount of time you're hitting the disk is reduced quite a bit, and Spark is able to process your data much faster than Hive and Hadoop, right? So basically, in terms of feature set, you will see that Spark, with its in-memory processing engine capabilities, it is still scalable, fault tolerant, and flexible, but it is much faster, right? So it's a faster data processing engine. So what is Apache Spark, right? At a high level from a user perspective, obviously, as we just discussed, it is a general purpose distributed processing engine, but there are multiple use cases that it caters to. Today, Spark has actually emerged as a standard for batch processing, for ETL processing, and it has been like catering to a lot of machine learning use cases. We see graph processing is another emerging use case in Spark, and stream processing is a very common use case that our customers use Spark for as well, right? And another big thing about Spark that makes it very easy to use is the support for multiple languages, right? So Spark, you can write Spark code in Scala and Java traditionally, but Spark also has Python API. So if you are a data scientist, or like, if you want to write some quick Python code to write your ETL, you will be able to do that in Python and even R actually. And Spark also has SQL API, so we do see some amount of data analysis. Personas such as data analysts are using Spark SQL to do data analysis on large data sets that are sitting on your data lake, right? And so with various APIs, you will see the adoption of Spark has been growing pretty well. And if you look at open source, the numbers speak for themselves. Today it has more than 1,700 contributors. You see about 300 to 400 code check-ins happen every month in the Spark code base in the open source. And the user mailing list is pretty active as well. You see about 300, 400 mails going across every month, where the community is asking questions, discussing various things in Spark, and getting answers to their use cases and so on. Right, so we spoke about Spark and what it is, what kind of use cases, but let's talk a little bit about how Spark fits into Qubole, what Qubole is, and how it will help you. Right, so Qubole is a data platform, right? A data platform on the cloud. It's a managed service that enables you to cater to multiple use cases for your data needs, right? So Qubole is mainly multi-cloud in the sense that you can take Qubole's data platform and run it on any of the major clouds out there, public clouds out there. For example, Amazon Web Services, Microsoft Azure, Oracle, and Google Cloud Platform. We have customers that are spread across all of them, right? And within each of these clouds, pretty much a Qubole platform is portable. What it means is that you can take your Spark workloads, let's say from Amazon Web Services, and immediately be able to run the same workloads on, let's say, Google Cloud Platform on top of Qubole platform, right? So with that portability, what exactly does Qubole does, right? So Qubole caters to multiple use case personas. So as a data engineer, you might want to bring your data to the data lake, and then you might want to do some ETL, some batch processing, some stream processing, and so on. So Qubole provides multiple engines for you to cater to those needs. So Spark is one of those engines for ETL and batch and streaming. But we also provide Hive, so using which you can do your ETL processing. We also provide Airflow as a service, right? Using Airflow, you can orchestrate your end-to-end jobs, right? Your end-to-end pipelines, add dependencies in terms of let's say you want to process certain ETL job after your data arrives, right? So Airflow kind of waits for the data to arrive and then trigger the ETL job. So that kind of dependencies you can create there, and then create your end-to-end production pipeline for your data processing. And for data engineering, we provide multiple ways of actually running your jobs. So you can author your jobs via a workbench that Qubole provides. You can use Qubole notebooks to author your ETL jobs. And if you like to prefer to use your own IDE to write your ETL jobs, we provide an SDK to run it on Qubole, or we also provide a REST API to run from your CI/CD pipelines and so on to run your jobs on Qubole. So pretty flexible, right? Depending on what your choice of authoring and running your pipelines are, Qubole provides various ways of doing it. And similarly for data analysts, we provide a SQL workbench using which you are able to basically do ad hoc analysis and reporting on any volumes of data, right? So let's say you have terabytes of data sitting in your data lake. You can quickly use the Qubole workbench to go do some SQL processing on it. And for that, we provide Presto as an engine, which is a SQL processing engine. And even we have customers who use HiveQL or who use Spark for such kind of analysis. Similarly, for data scientists, we provide, again, the full stack where they mainly use notebooks to write their data science workloads, machine learning workloads, right? So they fetch their data using SQL, and then they do some basic processing using SQL, and then when they run out of gas on SQL, they want to do some advanced analysis using, let's say, Python and R. They're able to use Qubole notebooks for, getting Python dependencies, and then run their machine learning models, and then deploy it into production for batch workloads. So to support the data scientists, we provide Apache Spark, and we provide TensorFlow as a service. So as you can see, Qubole is an end-to-end suite of data products, and both user experience and the engine stack that we provide, so that you can build your end-to-end data pipelines and put them into production. And to support all these different personas, we also have a lot of features catering to the platform admin as well. So we focus heavily on self-service access. So what it means is that a data engineer or a data scientist can be completely productive by themselves, without really depending on a data admin for, let's say, data access, or for procuring different data sets, or creating a cluster, procuring a cluster, and so on. So a data admin creates a cluster very quickly when you get the platform, and once you have the cluster, make it available for your data scientists or data engineers, and then you provide access to the data sets, and that's it. People can be very productive on top of Qubole. A general number that we talk about is for a platform admin, in general, people who manage their own data platforms, the admin is able to cater to maybe 10, 15, or 20 users at max. In Qubole, we typically see about 100 to 200 users being catered to by a single admin. So that actually directly translates to the benefit of self-service access. So with that, Qubole actually has more than 200 customers today, and our founders have actually created the Apache Hive project while they were working at Facebook, right? And right after Facebook, they came out and started Qubole, so that they can provide the similar type of features that they have been able to build and provide to their users in Facebook to the wider market outside. And as you can see, we have a lot of presence globally as well. We have 10 plus offices and so on. So about Spark, right? Spark on Qubole. Let's go deeper into Spark on Qubole. So Spark on Qubole is used pretty extensively in our customer base, right? So today, one of the biggest clusters that we see customers using has about 840 plus concurrent nodes. Right. So what it means is during a lifetime of a cluster, since it is on the cloud, you'll be getting multiple nodes coming in, going away, and so on. So typical cluster will have thousands of nodes during the lifetime of it. But this number actually is at any given point of time, what is the maximum number of nodes is a Spark cluster running on, right? So 840 is the maximum that we have seen, is which is pretty much one of the biggest clusters in the cloud. And in terms of growth, we have actually seen the number of Spark commands that run on Qubole grow more than 400% year over year, which is pretty significant. And last year alone, in 2018, we actually invoked more than 630,000 clusters. Spark clusters, right? So in Qubole, what happens is you create a cluster, which is essentially a template or a blueprint for the cluster. And whenever you need to run something, you just start the cluster, run it, and then shut it down, right? So a lot of times what happens is, customers have production jobs that just, switch on the cluster, run a series of Spark jobs, and then switch them off, right? That way you're saving a bunch of cost instead of running a cluster 24/7, spending your cost on it. You just run only for the time that you need it for. And so some of the examples of the customers we have, Lyft is a customer, Box is a customer. We have other big customers such as Adobe, Samsung, MediaMath. In general, what you will see is many of the internet-first companies, mobile-first companies, or ad tech companies, which heavily rely on real-time data, large volumes of data on the cloud, are heavy users of Qubole. So how do our customers use Spark today? Right, so in your end-to-end data platform, right, you have this flow of data where your data is getting generated all the way to the left on your, let's say, business applications, on your web applications, in your clusters, in your web clusters, right, your cluster logs, click streams or sensor and device data, all of this type of data. Typically, you move that data into either a data warehouse or to a message bus or to a data lake and so on. And then once you do move it to the data lake, then you start doing multiple types of processing on it to make this data useful and insightful for your end users. Right, so we have customers who use Spark to do multiple types of this processing. Some of our customers use Spark to directly ingest that data from the message bus into the cloud so that you can do further processing. Some of our customers do batch ingestion. They move Spark to load data from your data warehouses into data lake, right? And once you have the data available in the data lake or even directly from the message bus, we have customers, a lot of customers that actually directly read the data from the data lake for use cases such as machine learning, batch ETL, streaming ETL. These are pretty much majority of the use cases. And we have some customers who are also using Spark for SQL access to be able to do ad hoc analysis on the data. And a few customers, a relatively lower set of use cases, graph processing. So Spark also provides library to be able to do graph processing on Spark on your data lake. Right, and after this processing is done, either you write the data into a data warehouse or you can still keep it in the data lake. And we have a lot of customers who use engines such as Presto to do operational and analytical reporting on that particular data sets. At this point, so I would like to hand over to Harsh so that we can talk about a couple of customer use cases to dive deeper into how Qubole and Spark has actually helped our customers add value to their business.
Awesome. Thanks, Ashwin. I want to talk about a couple of our customers who've effectively used Spark and how their journey was before they started using Spark and how Spark fit as a perfect solution for them. And what were some of the value adds that were provided with the use of Spark on Qubole? So the first customer that I want to talk about is so Return Path. Before they moved to the cloud, they were completely on-prem. For any team, be it the analyst team or the data science team, they had to go through multiple hops to get their hands on the data that they wanted to perform some analysis on. This would create bottlenecks, and a lot of times people would miss their SLAs. And to add on top of it, there were multiple tools and applications that were spread out across the organization that resulted in a lot of data silos. There were teams that were probably running the same algorithms in their silos and not being able to reuse any of the work. So what they were able to do one of the solutions for them was first to move to the cloud. They chose AWS as their cloud provider. And once they moved to AWS, they were able to use S3 as the data lake. So all the data was pushed into S3, giving users a way that they could access the data. And then by using Qubole and using Spark on top of Qubole, the data scientists could directly run the notebooks and have access to the data without having to worry about going to multiple data engineering teams to get handle on those data sets. So they were able to self-serve and use a lot of the data themselves. And this resulted in them creating a lot of the recommendations and the algorithms that they planned to without having to go through the multiple hops that we just spoke about. And their tools or engines of choice was Spark, and they perform a lot of their machine learning using PySpark or Scala on Spark. What we saw for Return Path primarily was by moving to the cloud and using Qubole, their cloud costs was reduced just by the way the auto scaling and other elements were taken care of within the Qubole platform. And now the users were more productive because they didn't have to go and ask for data and wait multiple days before they could use these data sets. And this also helped the end customers were seeing the value just because they were able to perform all these operations before much faster than what they were initially able to. And the next case study, the next customer I want to talk about is Ibotta. Ibotta was already in the cloud. They were using a cloud data warehouse. And the issue that they were facing was as their data needs and data teams increased, the volume of data that they were working on the data warehouse, it was becoming very tough to scale. They were facing massive latency issues, and they were also facing cost issues because as you start storing more data in your data warehouse, it becomes expensive. And another thing was, since the data warehouse was the only source of truth, every team would want to run queries on the data warehouse, resulting in multiple issues where the people would step over each other's feet while they're running queries, and they would have high response times for the run of a particular query. And this also created a lot of the data engineering team and the infrastructure team would have to spend a lot of time trying to tune the data warehouse for the needs of all the users. As a solution, what Ibotta was able to do was they could use the data lake. They ported a lot of the data that they had in their data warehouse through ETL pipelines and put it into the data lake, and then have multiple teams use different engines that would suffice their needs. For ad hoc analysis, they were able to use Presto on Qubole and run fast queries without having to rely on the data warehouse. And for the machine learning, they could use Spark. So they were using Spark on the notebooks, and then this helped them deliver their output or the algorithms that they were trying to build. They were able to do that without having the hop from a data warehouse to their local laptop to running the algorithms. Now they could directly plug into the data lake, and since Qubole is cloud native too, they were able to run the algorithms on the notebooks right off the data lake, and eventually have all the information provided back into the data lake, or the summarized data sets put into the data warehouse. This strategy that Ibotta used to move from the data warehouse to a data lake and use Qubole as their data platform significantly reduced their cloud costs, somewhere around the ballpark of about 70 to 80% on what they were spending on compute on the data warehouse, and all the other things about productivity, and they were able to scale much faster. So all these became a part of their data platform. With this, I will hand it back to Ashwin to talk about some specific optimizations that we've done on Spark in Qubole.
All right. Yeah. Thanks a lot, Harsh. So as you can see, customers on Qubole have actually improved quite a bit on two main factors, right? So one factor is productivity. They have become a lot more productive, more agile in terms of putting their use cases in production. And then second thing is they have become very cost efficient because of a lot of platform level cost optimization and auto scaling features that Qubole provides. So let's talk a little bit about the optimizations on Qubole, right? So Spark on Qubole, basically we take open source Apache Spark, but also we add a layer of different features provide to our customers to enable them for various use cases and make it very efficient to run Spark on Qubole. Mainly we focus on 4 different areas of investment, right? So first thing is auto scaling that directly translates to cost. The second one is performance, right? So in terms of running your big data workloads, performance is always a number one priority so that you can run your workloads faster at scale. Right, and then we focus heavily on usability for various different personas we talked about, and we also focus heavily on enterprise features such as security and integrations. Right, so let me give you a few of the examples of what we do along these various dimensions, right? So for performance, we focus heavily on 3 different aspects. So how you're reading the data, how you're processing the data, and how you're writing the data back to your data lake, right? So some of the examples here are like, for example, we have the S3 direct writes, right? So today in the market, writing to S3 has eventual consistency issues, right? To solve that, a lot of the users who use open source Spark have actually found a workaround to write to HDFS and then move the data to S3, right? And that actually is very slow. And what we have done is actually solve the eventual consistency issues itself, right, while writing to Hive tables in S3, right? So when you are using Qubole Spark and writing to S3, you don't have to worry about the eventual consistency issues. And our benchmarks have shown like this change itself has given about 40x gains in that aspect, right? Similarly, we have done multiple other features such as dynamic filtering, metadata caching, S3 select. We have blogs on most of these features. So if you are technically inclined and want to learn more about how we did and what we did under the engine and how it is producing these types of benchmarks, you can go and refer to these blogs. Right. Another example here is the Rubix distributed cache. So we have built a platform caching layer called as Rubix, and we have open source data actually, right? Rubix, what it does is it's a file level caching layer where for repeated access of the same file data, what we do is we cache the blocks within the file from the S3 or from your object store, and then cache it into your cluster file system. And Rubix has the intelligence to cache the most frequently used and most recently used blocks, and also invalidate those blocks when the source file changes and things like that, right? So from a user perspective, it's a checkbox that you check on Qubole console on your clusters, and that's it. Your Spark application will start using Rubix in the backend, and our benchmarks have shown about 4x improvement over there. So heavy emphasis on performance. We keep adding more and more features for our end users so that your Spark pipelines run faster and efficiently. And the second big aspect is auto scaling, right? So for auto scaling, we have a bunch of features that we focus on. I'll give you one example. So workload aware auto scaling, right? So by default, if you take Open Source Apache Spark to scale up, it has a feature called as dynamic allocation, right? So what it does is every time you need more resources, it asks for double the number of executors. So let's say you're working on 10 executors today, it grows to 20 to 40, 40 to 80, 80 to 160, and so on. Right? As a result, as you can see, what happens is when you need, let's say, 10 more executors, and let's say you're at 100 executors, Spark actually by default grows to 200 executors, right? So in Cueball, we basically changed that algorithm, right? And we basically said we don't need to grow 2x every time. We'll grow to exactly the number of nodes that you actually need for processing your application, right? So the way Qubole does that is basically it looks at the SLA of the task execution. It looks at how many tasks are pending, how much time each task is taking to run, and how many tasks are coming up in the future, based on such different metrics. It calculates the exact number of executors that are needed, right? And then places them into either existing nodes or gets more nodes. And Qubole also has a feature called as container packing, where containers as close as possible to each other, because it's cloud, it's a scalable cluster. You don't have a fixed cluster, right? So why get many nodes when you can put them together in fewer nodes, right? And only bottleneck could be something like creating hotspots there for CPU memory and disk I/O. Qubole makes sure with container packing that you don't get those hotspots while you get the efficiency of running in as fewer nodes as possible, right? We see in general our customers saving about 50% of their costs on the cloud as that we talked about, while moving their workloads from, let's say, native cloud provided solutions or moving from on-prem to Qubole. And similarly, a lot of focus on usability, right? We provide multiple interfaces. So we provide notebooks, we provide SQL Workbench, a workbench to run Spark commands and then look at logs and all of that. Hirsch will go over the demo in a while. And we also have API, SDK, and so on. We provide scheduler and Airflow. If you want to do simple cron type of scheduling, time-based scheduling, you can use Qubole Scheduler. But if you have dependencies of various workflows that are running one after the other and have dependencies between each other, then we also provide Airflow as a service, right? And Qubole is a multi-user, multi-workload cluster, right? So there is a multi-tenancy available in Qubole at multiple levels, right? So each customer can have multiple accounts in Qubole, and each account you can have multiple clusters, right? And within each cluster you can provision the cluster workloads, right? So you create a Spark cluster and give it multiple data scientists and multiple data engineers, for example, right? So it's your choice as to how much level of multi-tenancy that you want to provide. We have customers who create a few 2 or 3 clusters, a dev cluster, production cluster, and so on, and then give access to it to multiple users, and they enable auto scaling on it. Qubole auto scaling is very efficient, so it caters to you, as a user, you provide a minimum number of nodes and a maximum number of nodes, and Qubole will scale your cluster up and down based on the demand, based on more number of workloads that are running over there. And another big usability piece is Spark Lens, right? So Qubole has created an open source project called as Spark Lens that enables you to profile Spark jobs, right? So today, Spark jobs scaling up is an iterative process. It's a trial and error process where users have to throw memory at it, throw more executors at it, and see if it is meeting the SLA, right? Instead, with Sparkless, what happens is it gives you metrics straight off with some predictions as to how your job will perform given a certain number of executors. So you'll see a nice graph of the execution time versus the number of executors and so on among various different metrics. It's in the open source, so you can go try it out on GitHub. And similarly, we have various third-party integrations. We integrate with data warehouses such as Snowflake or Redshift and BigQuery and so on, right? And we also have streaming integrations like Kafka, Kinesis. And for security, we provide HighAuth, Ranger, and encryption among various things, right? And one big thing about Spark on Qubole is we are multi-version. That means that as a user, you can select a specific version that you want. You can select, let's say, Spark 2.3 or Spark 2.4, Spark 2.0, and then run your workloads on it, right, depending on your needs. And we tend to bring in the latest versions of Spark as soon as they are available in open source. We take about 4 to 6 weeks of time in terms of our testing and integration into Cueball and making certain updates on it. But in general, 4 to 6 weeks is the timeline that you can see in terms of bringing the open source versions to make it available for our users to start consuming. At this point, having seen so many features and what Qubole and Spark on Cueball means, I'll hand it over to Harsh so that we can go over a demo so you can practically see how it looks like and what you can do on Cueball.
Sure. Thanks, Ashwin. Please share my screen. So before I start the demo, I'm going to center the demo on Spark, but Qubole is a data platform. So Cueball, like Ashwin pointed out, is multi-cloud. We are available on AWS, Azure, GCP, and Oracle Cloud, and we are multi-engine. So we have support for engines like Hadoop, Hive, Spark, Presto, and Airflow. All this is across all the clouds, and the demo that I'm going to show you is centric to Spark and centric to Spark on AWS right now, but all of this is available on all the other clouds. So I'm going to dive into the demo. This is the Cueball login screen. So as soon as you log in, this is your home page. You get a landscape of what's happening in the environment. What are the clusters that are running? What are the recent commands? And what were the notebooks that you have recently accessed or opened. So the first thing that I want to talk about is how simple it is to create a cluster. And then I'm going to talk about how we can run workloads on these clusters. And the last part that I'm going to talk about is how do you actually productionalize the workloads on these clusters using Airflow. This is the cluster screen. You see, in this case, there are 3 clusters that are running in my account. There are 2 Spark clusters and 1 Airflow cluster that's running. Let me quickly show you how simple it is to create a cluster template. So we choose, we click on Spark, and after we click on Spark, then we next, and we give the cluster a label. We say dev_Spark, for example. And like Ashwin pointed out, we support various versions of Spark. So right now, the version that we support, the latest version we support is 2.4. We're about 2 to 4 weeks behind, 4 to 6 weeks behind an open source release. As soon as the open source releases Spark, we do our internal test and we incorporate the Spark version within the platform. And this is the part where you start configuring the clusters page. This is a specific Spark cluster. You choose the instance types that you want for the master and the worker nodes. And this is where the intelligence comes in. All you have to define is the minimum number of worker nodes and the maximum number of worker nodes. And the auto scaling will take care of it itself. What will happen is you spin up the cluster. As the workloads start coming in, we are able to figure out whether they are pending young containers and at what is the SLA associated with them and how quickly are those containers finishing. And based on that, we add the nodes and the cluster scale up. And like Ashwin pointed out, we have intelligence baked in like container packing, which helps to downscale these clusters really quickly. As soon as the workloads are finished, as soon as you finish those workloads, the clusters would be terminated. In this case, you have no intervention. You don't have to worry about rules. You don't have to worry about specific heuristics. You don't have to look at, okay, the memory thresholds are this much, so I should add X number of nodes. Or if you're using Spark specifically, it's not exponential on the executor base. All of it is taken care of, and it is intelligent. Like you saw with the customer case studies we spoke about, they were about 40 to 60% in cloud savings by default, and some go higher depending on how they use the cloud, whether they use a lot of spot nodes within their cluster composition. So this is just about the auto scaling piece of it. Now you talk about the composition of the clusters. You could have in the AWS world, they're called spot nodes. In the GCP world, they're called preemptible VMs. These are low cost machines that can be used, but they come with a caveat where they could be in AWS, they could be taken away from you in a 2-minute window. So they'll give you a 2-minute notice and the machine will be taken away from you. So all this is baked into the platform. So we have stuff like spot rebalancing and fallback on on-demand node. All that is a part of the Qubole platform. That's and in this case, the default is 50% for spot nodes in a cluster composition, but we see customers who go as high as 80 to 90% too. And and the other things would be where do you want to, which VPCs, where do you want to launch the clusters, whether it's in a private subnet, then you'd want a bastion in the public subnet of that VPC. All those configurations can be done through this cluster configuration page. And it's all available here. Like we spoke about before, you could also create these cluster templates using our SDKs and the REST APIs. You don't have to use the UI specifically. Everything that I show you in the UI through the demo is available through the REST APIs too. So you could provision it as a part of your CI/CD pipeline, or if you have automation already baked in, you could use leverage the REST APIs to provision any of the clusters and run workloads on it. This was very centric about creating the underlying Spark clusters. The next part is, now you have the cluster, now you want to run workloads. What do? There are two ways you can run workloads. One is the collaborative workbench that you see right now. This shows you a place where you can compose a query. So the last few queries that I've composed are Spark queries, and it's collaborative. So everyone within your account has access to these queries. So this is my specific account, my specific user, but I could drill down and get information of what queries other users have spun. That helps me to understand what's happening, or if I have to reuse a query, I could just reuse the query rather than writing the whole query or the code myself. So it helps that way. And from a composition perspective, in Spark, you could just choose a Spark as the engine that you want to use to run the query. It could be Scala, Python, command line, SQL, or R. And you could choose the cluster that the query runs on. Some of the intelligence that we bake into the platform is, suppose you submit a query and the cluster is down, you don't have to manually intervene to start the cluster. The query will figure out that, okay, the cluster is down right now, so let me start the cluster. And as the query completes, the cluster will terminate on its own. So there is no human intervention required in this case. What you also see along with the code that you've written in the workbench is the results and the logs. All of it is available to you in one centralized place. Not only does it help with the collaboration element, but it also helps you get all the logs and all the information in one place. So all the resource information, everything is available here. If you want to go to your UI, you can navigate from this page. Similarly, the queries have a permalink associated with it. You can copy this permalink, share it with another user within the account, and this query will pop up for that user, and then he or she can do the due diligence of either rerunning this query or optimizing it depending on what's required. So that's one way you can actually run workloads on a Spark cluster or any of the clusters. In this case, if you look, the options are you could use Presto, it could be Hadoop, or it could be Hive also. The next way of running workloads, what we see typically with the data science persona, is they like to use the notebooks. So in Qubole, notebooks are a part of the Qubole platform. So the notebooks will be available to you within the platform. and it's collaborative too. All the notebooks have a permalink associated with them, and we have GitHub integration associated with the notebooks too. I'll go through a simple example of a notebook. This is just a machine learning algorithm that's based that we've created for recommendations. What you see on the first paragraph is a typical workflow for a machine learning pipeline. Before you start modeling or training and testing, the first step always is to acquire the data and run ETL pipeline so you can cleanse the data. How that happens would be, for example, the data comes in your data lake. Then you want to run some ETL pipelines on those data so that you could clean that data and it's in a format that is understandable by the machine learning algorithms. In the first step, what you would do would be you would have an ETL pipeline running in Airflow at a particular schedule. So you could have a daily pipeline that runs, gets the data from the data lake, cleanses the data and puts it in buckets which the data science team or the algorithms would use in the next step. Once the data is ready and cleansed, the second step is now you want to train the algorithms or test some of the hypotheses that you have. You do that using the Qubole notebooks like you see right now, and you could run those models within the notebooks and then figure out how the models are performing. Once you're sure the models are performing fine, you could deploy those models. Either it could be a batch deployment or a real-time deployment. One of the things in this case is, again, like Ashwin mentioned, even when you want to do some machine learning, you would there would be some SQL that you want to interact with just to make sure that the data is working fine. So you could write some SQL over here. Then once you're sure that the SQL is working fine, you want to create some tables. You could create those tables and then run your algorithms or run your functions on top of those data sets. And the visualizations are available here. You could, if you have matplotlib or plotly, you could put them as a part of the notebooks. And your Spark jobs that run, you have all the information available here. And normally it would be you write your SQL. Once the SQL show that SQL works fine, then you would start running your Scala or Python or PySpark jobs on top of those data sets. And there are two ways that you would work with these notebooks. One is, okay, now you're sure that the notebook works fine. Now you want to deploy it into production. You could have a schedule that runs and invokes these notebooks at a schedule. This could be done through Airflow. Or the other way that we see a lot of customers use the notebook interface is they use dashboards. These notebooks can be converted into dashboards. And those dashboards are read-only dashboards where you see all the visualizations. All the code is removed. The visualization tabular content is available, and they could be put in kiosks or some place where people want to just see that, okay, how is everything performing? How are the models working? Or how are some of the reports coming in? You could get that all through the dashboards. That is, again, one thing about how you run the workloads. The next element is once you've run some ad hoc workloads or you have trained your models, you would want to deploy it into production. What we see a lot of customers do is they use Airflow. Airflow is a scheduler, and Airflow, we provide Airflow as a service within Qubole. What does that mean? If you go to the clusters page over here, there is this Airflow cluster over here. You get all the information about the Airflow cluster. What are the web servers? What are the DAGs? What is happening in Airflow? You get everything in one centralized place. So let me just quickly glance through a DAG and show you how easy it is. And it's in one place, so it shows you the whole end-to-end ETL pipeline where you get the data from your data lake, run ETL, and then eventually put it back into your data lake or the underlying data source that you want. So this is the Airflow cluster. This shows all the DAGs that are within my environment. I will just go to one. So this DAG, it's run successfully 4 times. What's happened and how were the runs of this particular DAG. I'll get this information here, and I'll click on the DAG. It gives me the information about, okay, so this is what the DAG does. This is the pipeline for the DAG. It gets the information for the movie lens database, puts it into S3, and then runs the Spark notebook that I showed you before. And then what you also want to see is, okay, so this is what happened. These are the steps. Now I want to drill down and actually see, okay, what was the actual code that was run? So it's as simple as going here, clicking on go to QDS, and this command will be available to you on the user interface. So it's as simple as that. And all the information over here of Airflow is available to you within the Qubole interface. To summarize, what I wanted to show you was how simple it is to create these Spark clusters and the intelligence that is baked into these Spark clusters, including workload-aware auto-scaling and everything around that. Then how are the different ways you can interact with the clusters to run your workloads? One is the analyze interface, where you run your run your workloads, and the second is the notebooks, where you can run machine learning workloads, or you can do some amount of ad hoc reports. And the last part was running ETL pipelines through Airflow.
All right, thanks a lot, Harsh. So that demo was pretty insightful, right? As you can see, we can mix and match different types of workloads into your Airflow end-to-end orchestration. You could import your data, and then you can use Hive, you can use Spark, and you can have your machine learning algorithm and put them all in single dependency graph, right? And if something fails, or if you have to go drill down into what each of those tasks are, you can directly click on a button and just go to the specific Spark job and look at its logs and look at what exactly it is doing and so on. So it's pretty useful. In terms of putting things into production on Cueball in the context of Spark and mixing and matching with different engines over there. So with that, I think we conclude the webinar. And basically, as you can see, just to summarize, Spark is a distributed processing engine, and it helps you process large volumes of data in memory, so it is fast, and it caters to multiple use cases. And we provide Spark as a service via various interfaces so that you can be very productive and put things into production. If you want to try Qubole, it's very easy. Quickly go to qubole.com/test drive, and you will be able to very quickly get started on trying out the various features that Qubole provides and run some Spark jobs on it. You can choose your choice of cloud to run it on. So we are on AWS, GCP, Oracle, and Azure. So you can select any of those in test drive as well. I think I'll pass it on to Steve now.
Great. Thanks, Ashwin. Thanks, Harsh. We do have one question, but I also want to pause in case anybody else has additional ones. Please feel free to submit them, and we'll cover them. As Ashwin mentioned, I would encourage everyone to check out Qubole and Spark on Qubole by going to test drive. The link is also in the attachments and links section. If you're looking for it there, we've also included a free ebook and some more technical comparisons between open source and Spark on Qubole. With that, in Ashton, I think the question was actually referring to the Spark enhancements. The question is, what does multi-user, multi-workload clusters mean, and why would you take advantage of that?
Sure. So basically, multi-user, multi-workload clusters are basically a single cluster where you can provide access to it to multiple users. Right. For example, you have 10 data scientists. They all will be able to use the same cluster, Spark cluster. You don't have to provision a separate Spark cluster for them, right? So when you do that, what happens is, number one, your cluster utilization is high. 10 data scientists, 10 clusters means there is a lot of underutilized resources. But in Qubole, what you can do is one cluster, have 10 data scientists use it. And with the granular auto scaling features that Qubole provides, the cluster scales up and down dynamically. Right. As a result, what happens is all are productive and they are able to utilize the cluster to the maximum. But the cluster costs are actually pretty efficient. You're not spending 3 times, 4 times for 10 different clusters. Instead, one cluster, both productivity is achieved at a reasonable cost.
Perfect. All right, I'll pause to see if any other questions come in. Okay, great. With that, thank you again, Ashwin and Harsh, for presenting today and taking us through the demo. And thank you to everyone else for joining us. Hopefully you found that valuable. We'll be hosting a series of webinars over the next couple of weeks, one of them focused specifically on Qubole on GCP, and another one focused on data engineering best practices. So keep an eye out for those. And thank you again for spending the hour with us. All right, have a good day.